Applications on system development. Database systems. A database system can be used as a general mechanism for defining, storing, and manipulating data without writing specific programs to perform these functions. A database management system (DBMS) provides high-level commands to operate on the data in the database. DBMS also provides protection and security to the databases and maintains data consistency in case of multiple users. Some examples of popular DBMS used today are MySQL, Oracle SQL Server, IBM DB2, and Amazon Simple DB, which is a cloud-based management system. Types of databases. Firstly, we have hierarchical, where the data is organized into a tree-like structure. Secondly, relational, where tables are used to fit data into a predefined category. Third, we have the object-oriented, where data is organized around objects. And lastly, we have mesh. Database security issues. Firstly, no security testing before deployment. Although functional testing is conducted to ensure supreme performance, this test does not show if the database is doing something that it is not supposed to. Secondly, feeble cybersecurity software. Most businesses does not bother to conduct user data security testing and do not provide regular patches for their systems, thus leaving their systems susceptible to leaks. Stolen database backups. Although there are many external security issues, some companies have a problem of internal threats where employees with access to sensitive data can steal it and sell it to a third party for profit. This can be prevented by encrypting the database archives and implementing more strict security standards. Next is aggregation, which is the act of obtaining information of a higher sensitivity by combining information from lower levels of sensitivity. This information is then packaged into aggregate reports and then sold to businesses as well as local, state, and government agencies. The information can be used for marketing or consumer reporting. Open Database Connectivity is a Microsoft-developed standard for supporting access to databases through different applications. This access must be controlled to avoid compromising the database. Application controls. Application controls are used to enforce the organization's security policy and procedures, and to maintain the confidentiality, integrity, and availability of information. Application security involves the input to the system, the data being processed, and the output of the system. Some key features of the application controls are to automatically identify trusted software that has authorization to run, to eliminate unknown and unwanted applications, to reduce the risk and cost associated with malware, and to improve the overall network stability. Service level agreement. A service level agreement guarantees the quality of the service to a subscriber by a network delivered service and are useful in anticipating, identifying, and correcting problems. Some of the metrics in service level agreements are as follows: turnaround times, average response times, number of online users, system utilization rate, system uptimes, volume of transactions, and production problems. Application control types. Preventative controls describe any security measure that is designed to stop unwanted or unauthorized activity from occurring. Examples include physical controls such as fences, locks, and alarm systems. Technical controls such as antivirus software, firewalls, and IPSs. Administrative controls like separation of duties, data classification, and auditing. Next, we have detective controls, which is any security measure taken or solution that is implemented to detect and to alert to unwanted or unauthorized activity in progress or after it has occurred. Physical examples include alarms or notification from physical sensors. For example, door alarms or fire alarms that alert guards, police, or system administrators. Some examples of technical detective controls are honeypots and IDSs. Lastly, corrective controls include any measure taken to repair damage or to restore resources and capabilities to their state following an unauthorized or unwanted activity. Examples of technical corrective controls include patching a system, quarantining a virus, terminating a process, or rebooting a system. Putting an incident response plan into action is an example of administrative control. Distributed systems. A distributed system contains multiple nodes that are physically separate but linked together using a network. All the nodes in this system communicate and handle processes in tandem. This is an example of a distributed system where the computer network connects to the different nodes, which are represented by site 1, site 2, site 3, site 4, with the different databases connected to them. Types of distributed systems. Client-server system and peer-to-peer systems. Client-server system. In this system, the client requests a resource and the server provides a resource. A server can serve multiple clients at the same time while a client is in contact with only one server. Both the client and the server communicate via a distributed network. An example of a client-server system would be an ATM machine, which is connected via the bank's distributed network. Peer-to-peer systems. These systems contain nodes that are equal participants in data sharing. All the tasks are equally divided between all the nodes, and the nodes interact with each other as required as a shared resource. Peers are both suppliers and consumers of resources. Advantages of distributed systems. Some advantages of distributed systems are as follows. All the nodes in the distributed system are connected to each other, so nodes can easily share the data with other nodes. More nodes can easily be added to the distributed system and can be scaled as required. Failure of one node does not lead to the failure of the entire distributed system. Other nodes can still communicate with each other. Resources like printers can be shared with multiple nodes rather than being restricted to just one. Disadvantages of distributed systems. Some disadvantages of distributed systems are as follows. Firstly, it is difficult to provide adequate security for distributed systems because all nodes and connections need to be secured. Secondly, overloading may occur in the network if all nodes of the distributed system try to send data at the same time. Lastly, the database connected to the distributed network is quite complicated and difficult to handle as compared to a single user system. Centralized architecture. A centralized architecture implies the availability of a single or few entities that have control over the entire network. The most important task within this architecture is to generate and to distribute security keys to all the members via a pairwise secure channel established with each member. Centralized systems have their risk, for instance, a single point of failure. That being said, if the company goes out of business, all the data is gone forever. Examples of centralized systems are social media applications such as Facebook and Twitter. On the right, we can see a diagram with a centralized database. This means if the centralized database goes down, the architecture will fail as everything links back to the one database. Real-time systems. Real-time systems operate by acquiring data from transducers or sensors in real time and then making computations and control decisions on a fixed time window. An example of a real-time system would be a fly-by-wire control of supersonic aircraft where adjustment of plane controls is time crucial. Real-time systems. Real-time systems operate by acquiring data from transducers or sensors in real time and then making computations and control decisions on a fixed time window. An example of a real-time system would be a fly-by-wire control of supersonic aircraft where adjustment of plane controls is time crucial.